Alright, so on the last class we started talking about the slope-intercept equation of a line. You might remember that's the thing that looks like y equals mx plus b, where m and b are both numbers. So for example, y equals 2x plus 1 would be an example of a slope-intercept equation of a line. And the idea is, again, that this is relating to quantities. So x is representing something, and it's going to be our input quantity, and y is representing something, and it's going to be our output quantity. Somehow these two things are related, which means for any input I can find an output, and for any output I can find an input. Okay, so in this equation, you might remember b tells us the y-intercept of the graph. So if we saw a graph of this line, let's say it looks like this, then this point right here is going to correspond to our value for b. M, you might remember, is our slope, and that gives us our rate of change. It says if we go over and up, how much over do I go relative to my up? Or in other words, what's we said rise over 1 was one way to think about it. We also said we could do difference of the y values over difference of the x values, different ways to calculate slope. Okay, so let's take a look at a line here. So here's the graph of a line, and let's see if we can write an equation for the line. So why don't you give this a try first? So let's see what you came up with. So notice that the graph crosses our y-axis at 6. So our y-intercept is 6. And then we need a slope. And because we got a nice little grid here, we can just go ahead and say I go over 1 up 2. So my slope is 2 over 1 is 2. And then I can write the equation for my line. Y is slope times x plus my y-intercept. Great. So now let's try another one. So now let's try graphing y equals negative 2/3 x plus 2. Go ahead, give it a try. So if we want to graph this, there's sort of two ways we can do it, which we talked about last class. One is we can calculate out pairs of values. So for example, I could say when x is 0, my output value would be, my y would be negative 2/3 times 0 plus 2. And 0 times anything is 0 plus 2 is 2. And then I could pick some other value for x, and I'm going to pick 3 because it looks like a nice value. So y would be negative 2/3 times 3 plus 2. If those cancels, I end up with negative 2 plus 2 is 0. So I got 0, 2, and 3, 0. And so oops, that's a pretty bad looking line there, but oh well. Anyway, we get a line that looks, well, something like that. We could, of course, also graph it a different way. We could say my y-intercept is 2, and this tells me, my slope tells me negative 2 over 3. That I'm going to rise negative 2 for a run of 3, which means I'm going to go down 2 and over 3, and I could get my next point that way, and then down 2 over 3. Over 3, 2. So down 2 over 3, right? And that can be a nice way to graph a line as well. Okay, so now let's transition a little bit. So let's transition and sort of moving away a little bit from what we talked about before. Let's look at sort of another application of this sort of slope-intercept idea. So let's think about this situation. A prepaid cell plan charges a $10 activation fee and 15 cents per minute. So when we see something like this and we want to come up with an equation, we can ask ourselves what quantities are changing. So what quantities are involved in this problem? And there's sort of two quantities, right? There's money, there's cost, and then there's minutes, right? There's time going on. So we have two quantities that change, and they change together. When one changes, the other changes. And so we're going to identify one of these as being our independent variable. That's the one that sort of gets to be whatever it wants. And then the other one's going to be our dependent variable. In other words, it depends upon the first one. So in this case, which of these depends upon the other? Well, you can probably tell that money is going to depend upon the number of minutes. So this is going to be my output, or what we call dependent variable. And then this one is going to be my input, which we also call independent variable. And I actually want some variables here. So I'm going to go ahead and do M for money and maybe T for minutes to represent time. I don't want to use the same letter for both. So if we think back to my slope intercept equation here, y equals mx plus b, notice I don't have a y. Oh, actually I'm going to change my m here so that we don't get confused. I'm going to call this d for dollars. We don't have a y and an x here. So instead of writing y equals mx plus b, I'm going to write d equals mt plus b, because instead of x I'm using t for my input, and instead of y I'm using d. Now if you really don't like this idea, just go ahead and use x for the minutes and y for the money, and everything will work out just fine. So now let's see if we can write an equation. Now when you first saw this problem, you probably said, I already know how to write an equation for this. We've done this before, David. Okay, well, tell me then, what should it be? So you may have said to yourself, well, this is kind of like those ramen problems we did in those in other ones. My money is going to be, well, I always have to pay $10, and then it increases by 15 cents for each. Sorry, my writing here. 15 cents for each minute. And you'd be exactly right. D equals 10 plus 0.15 t. But notice that this really is a slope-intercept equation, or at least if we maybe rearrange these two and wrote it this way. Right? Now it looks like this. So which part's the slope, which part's the intercept? This part here is my slope, and this part here is my intercept. Notice that this makes a lot of sense. The intercept tells me my y value, or my output value, when the input is 0. So in this case, it tells me my amount of money when my minutes are 0. I pay $10 when I haven't talked at all. So this is my starting amount. You can also think of this as starting amount. And then slope, remember, talks about rise over run, or output over input. So slope, you might remember, slope is change in the output over a change in the input. And what are the units on our outputs? Well, our outputs are money. They're measured in dollars. What are our input? Our input was minutes. And so our slope, this number here, is going to be dollars per minute. Dollars per minute, which is a slope. Whenever we see a something per something type quantity, we really should be thinking, oh, that sounds like a rate of change. That sounds like a slope. Okay, so let's try another one. So the value of my car is currently $6,000, but it's dropping by $1,000 per year. So again, let's start out by identifying our variables. So we've got the value of my car, and that is measured in dollars. And then we've got, looks like years going on. So maybe I'll use T for time again. I don't like using Y for years because it gets confusing. So we're going to do time in years. And so notice that my output, my vertical intercept here, my y-intercept, is going to be a value for v. It's going to be a starting value for v. And my slope should be $1 per year. And look at this, $1,000 a year, $1,000 per year. So can you take this and put it together into an equation? So hopefully you said, I know that my v value is going to be slope times my input plus my y-intercept. In this case, my starting value, my intercept is 6,000. My rate of change, my slope, is 1,000. So we end up with 1,000t plus 6,000. Okay, so now let's look at another one. And you're probably going, oh my god, I've seen this before. Yes, you have. And we can do exactly the same thing here. Again, we can say, okay, what are my inputs and what are my outputs? And in this case, the number of dots is depending upon something, and the thing it's depending upon is the stage number, which stage we're in. Now, this is going to go a little beyond what this section is actually talking about, because we have a little problem here. We don't know the starting amount. We don't know the starting amount because if you think about this equation, 6,000 is the value when the time is 0. Right? Just like here, $10 is the cost when the number of minutes is 0. We don't know the number of dots when the stage is 0. And so in order to do this, we're going to have to improvise a little bit, and we're going to have to say, what would stage 0 look like? So, yeah, you notice you got 1 dot in the middle, 3 dots out here, 1 dot in the middle, 2 dots out here, 1 dot in the middle, 1 dot out there. So we might guess that stage 0 would just be a single dot. So noting that, we could say we start with 1 dot, and then what happens each time? Each time, are we adding something each time? Yeah, right, each time we are adding 4 each stage. So if we notice that we're starting with 1 dot and we're adding 4 dots each stage, could we write an equation for the number of dots in, okay, so let's call this variable n, our number of dots, and let's call this, s for stage. Could you write an equation for the number of dots in stage s? So hopefully you came up with, we start with, well, okay, so if we think m s plus b, then my slope is 4, because we increase by 4 each time, and we started with 1. So 4 times s plus 1, and it would be perfectly fine to write it this way too. In fact, I think this is a little more intuitive. We start with 1 and we increase by 4 each time. Okay? And so look at all this stuff that we can do with linear equations, and this is just giving us another way to think about it. Okay, so now let's try something a little different. Here's an equation, 4x minus 2y equals 8, and we want to graph that. Now, this is a different kind of equation than we had before. And so it might be helpful to think about it in a different way. We're not going to do this yet. But remember the way that we graphed all of our other equations. For all of our other equations, we picked an x, and we figured out what y was. We picked an x, we figured out what y is. So let's do the same thing here. I can say to myself, let's let x equal 1. Excuse me. So if x is 1, let's look at my equation here. So I'm going to take this thing, and I'm going to let x equal 1. 4 times 1 minus 2y equals 8. So 4 minus 2y equals 8. And now I can solve for y. Negative 2y equals 4. Divide both sides by negative 2. Sorry for my writing here. And y equals negative 2. So when x is 1, y must be negative 2. So go ahead and find a couple more points here, and then graph the line. And I'll give you a hint. It'd be a really good idea to try finding the point when x is 0, and maybe try finding the point when y is 0. So, let's go ahead and figure these out. So when x is 0, here, when x is 0, I get 4 times 0 minus 2y, equals 8. And 4 times 0 is really nice, right? Because 4 times 0 is just 0. Divide by negative 2, and I get negative 4 out as my y value. Now, because of the way this is written, it works really well to do the same thing, but with y equal to 0. So when y is 0, I get 4 times x minus 2 times y equals 8. And again, 2 times 0 is really nice. And so I can divide by 4, and I get x equals 2. So let's go ahead and plot these. So this point, we didn't really need, but since I got it, I'll go ahead and graph it. This point is 0, negative 4. Notice that that's my y-intercept. This point, 2, 0, is something we'd call the x-intercept, right? Because x is along the horizontal, y is along the vertical. So this would be my x-intercept. And now I can connect my dots ever so gracefully and graph my line. Okay, so there is the graph of my line. So now we are going to try something a little different with this equation. We're going to take this same equation, and can we rewrite it into slope-intercept form? And remember, slope-intercept form means it's got to look like y equals mx plus b. So try taking this equation and see if you can figure out how to do this. See if you can rewrite this equation to look like this. I'll give you a hint. This is the same as what we were doing in formulas when we solved for a variable. So try solving this for y. So let's give it a shot. So 4x minus 2y equals 8. We can subtract 4x from both sides, which gives me negative 2y equals 8 minus 4x. And now we can divide both sides by negative 2. And we get, hold on, I'm going to make some room here because I'm writing pretty big here. So I end up with y equals 8 minus 4x over negative 2. Now, this is kind of okay as an answer, but it's not ideal. It's not ideal because we really would like this to be in that y equals mx plus b form, which isn't quite what this looks like. So to get it a little further, I'm going to go ahead and break this apart. And I'm going to say 8 minus 4x over negative 2 is the same as 8 over negative 2 plus negative 4x over negative 2. Or, if that doesn't make sense to you, you also could have said this. So 8 minus 4x, whoa! Somebody yell at me. Put an extra x in there. There we are. So 8 minus 4x all over negative 2 is the same as 8 over negative 2 minus 4x over negative 2. Actually, I'll leave it like this. So then 8 over negative 2 is negative 4, minus 4x over negative 2. 4 over negative 2 is negative 2, so that'd be negative 2x. Negative and negative make positive, so negative 4x plus, negative 4 plus 2x, or if we rearrange the order of these, 2x minus 4. And you'll notice that really matches up with what we're seeing here. A y-intercept at 4, and a slope of 2, so over 1 up 2, right? And so there we go. There is rewriting this equation into slope-intercept form. So the one last thing for us to talk about is horizontal and vertical lines. So far, all the lines we've looked at have been slanty, but there's nothing sacred about that. So for example, we might have a line that looks like that. So what can you tell me about this equation? What is, let's say this is at 5. So what's the y-intercept of this line? Well, it's 5, right? Well, what's the slope? Well, let's think about 2 points, here and here. To get from here to here, maybe I run 1. How much did I rise? I rose 0, right? So I'd have 0 over 1 is 0 as the slope. So the equation of this line would be y equals 0x plus 5 And of course 0 times x is always going to be 0. So this is just y equals 5. Now notice there's no x in this equation, and when there's no x, it basically means x can be anything it wants. So this equation says y is 5, no matter what x is. And we get this line here, a line showing all the points where y is 5. So, take a wild guess here. If we were to graph this line, what do you think its equation would be? Well, if you guess correctly, the equation of this line is x equals 3. This is telling us x is 3 no matter what y is. Notice that this one is not in slope-intercept form. In fact, this line has an undefined slope. And that's because if we pick 2 points, we'd have a rise of 1, but a run of 0, and dividing by 0 isn't something we can do. It's undefined. And so this line has an undefined slope. And there we go. That is the rest of this section on slope and intercept equations. Next class we'll talk about what to do if we have a line and a couple points, but none of them are the y-intercept. So we'll talk about how to find the y-intercept next time.